Hello, my fellow chemists. In this video, I'm going to introduce you to some basic facts about the periodic table. This is listed as a basic video because there's really no background information that you need to understand to be able to follow along with what I'm going to be talking about today. So let's get started. In the periodic table, the elements are listed by symbols which are one or two letter abbreviations. Some of the symbols make sense, like if we take a look at H here, that's for hydrogen. H for hydrogen makes sense. We see He over here, that's for helium. He for helium makes sense. Another important one here, C for carbon. That's one of the most important elements in organic chemistry. C for carbon makes sense, but some of them don't make sense. Like if you take a look here, Fe for iron, that doesn't really make sense. Well, that's because iron is Fe is ferrous, which is derived from the Greek term for iron. So a lot of the one or two letter symbols do make sense. They kind of sound like what the element is, but a couple of them don't. So those are the symbols in the periodic table. The next thing that we want to take a look at is, why is the periodic table shaped the way that it is? Why isn't it just like a regular box? Why does it kind of look like this box with a crease in the middle of it here, and then it goes up and down and up over the top there again? Well, that's because in 1869, a Russian chemist named Dmitry Mendeleev, and that's him in the bottom left corner of the screen there, that happening looking guy, he invented, or discovered, I should say, the periodic table. And what he was doing was he was organizing the known elements at that time based on their atomic numbers. And the atomic numbers are these small numbers at the top of each element. So if we take a look for hydrogen, its atomic number is 1. And the atomic number is just telling you how many protons an element has. So the atomic number is basically the number of protons that an element has. Every hydrogen in the universe has 1 proton. So if you took a hydrogen and you added a proton into it, it would no longer be a hydrogen. It would then be a helium because it would have 2 protons. So every helium in the universe has 2 protons in it. Every hydrogen has 1. If you go back down again and look at carbon, element number 6, every carbon in the universe has 6 protons. And you can see this is how elements are arranged in the periodic table. They're arranged in orders of increasing atomic numbers or increasing numbers of protons. Well, Dmitry Mendeleev in 1869 was arranging these elements by order of increasing atomic number or increasing number of protons, and he found that elements at periodic intervals have similar properties. So what does that mean? Well, he took a look, say, at hydrogen first, and he just plopped that down somewhere on a piece of paper, or, a drawing for hydrogen. Then he looked at element number 2. He looked at helium, and he saw, well, helium does not have any similar properties to hydrogen, so he just kind of put that in its own area as well. But then when he looked at the third element, when he looked at lithium over here, he saw that lithium had a lot of similar properties to hydrogen. So we put lithium underneath hydrogen. And that is then what we call a group. Groups are when you have elements that are in the same column as each other. So lithium and hydrogen started their own group. There are 18 groups in the periodic table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But, Dimitri, what are you doing? I told you I was going to introduce you at the beginning of the video. I did that. Yeah, all right. We'll go out for a beer when I'm done, but you got to let me finish the lesson first. All right. Thank you. Sorry about that. Where was I? 17 and 18. All right. So there are 18 groups. Those are the columns going up and down. And as Dmitri found that the third element had similar properties to the first element, lithium and hydrogen, he put them under the lithium underneath the hydrogen. Then if you looked at the fourth element, beryllium, that didn't have properties that matched up with anything else, so he just kind of put it in its own group or column. Then the fifth element, sixth, seventh, eighth, and ninth, none of them had similar properties to anything, so they kind of got their own group. But the 10th element, neon, had very similar properties to helium. So I put neon underneath helium, and those two were in group 18. Then if you went on element number 11, sodium had similar properties to hydrogen and lithium. So they went in the same group as lithium and hydrogen. So sodium, lithium, and hydrogen were all in the same group. And then he went on with all of the elements in the periodic table based on their atomic number. And eventually he mapped them all out, and he got this strange shape that we have nowadays for the periodic table. So other than just being listed by groups, which are the elements going up and down in the periodic table, you also have periods in the periodic table. And periods are what goes across in a periodic table. And there are 1, 2, 3, 4, 5, 6, 7 periods in the periodic table. Now, this group and period system is very useful in kind of triangulating where an element is. So you could say to someone, okay, which element is in group 13 and period 2? Okay, so you would just go over to group 13 here, and then you would go down to period 2, and you would see that is boron. Or you could say, well, what element is in period 3 and group 15? Okay, well, you go down to period 3 here, and then you would go all the way across until you got to group 15, and that would be phosphorus. So kind of using the group and period method is a very good way to triangulate or tell where an element is in the periodic table. All right, so today what we talked about was how the periodic table got its shape. We talked about how the elements have one or two letter symbols. And we said how these whole numbers at the top of the periodic table, those are the number of protons in each element, and they're called the atomic number. And then we talked about how you have groups and periods to recognize where elements are in the periodic table. In the next video, we're going to take a look at metals, how you can tell where metals are in the periodic table, and then also take a look at several groups of atoms that have very similar properties, and then they have specific names for those groups because of the properties that they have with each other. I hope you learned something today. If you did, make sure you subscribe and like, and I will see you in the next video.